This lesson is on adding and subtracting polynomials. When you're dealing with polynomials and you want to add or subtract them, essentially what you're going to look for first is you're going to look for what we call like terms. And that means that the same base has the same exponent. And so what you would then do is you essentially would add or subtract the coefficients. Those are the numbers in the front. And then you would keep the base, whatever that base unit's going to be. So we're dealing with polynomials. A polynomial is a monomial, binomial, some of them. Essentially you're adding or subtracting a bunch of monomials together. Let me show you what a monomial looks like. Monomial could be something like 3x. It's just one term. Or it could be something like the number 5. Or it could be something like negative 2x cubed. But the main thing is here is our variables in the numerator position. What's not allowed is you're not allowed to have something like 5 over x. That is not a monomial. So you cannot have the variable in the denominator. Another thing is that we talk about the degree of a polynomial. The degree of a polynomial is the exponent with the greatest value. So for example, let's say I have like 5x cubed plus 2x to the 5th minus 7x to the 9th plus 8. And we want to know what's the degree of this polynomial. We'll look at the exponents attached to your base, which would be x, and the one that has the greatest value would be this 9. So the degree of this polynomial is actually 9. Alright, so let's talk about the difference between these. See, a polynomial is made up by a sum or difference of monomials. So again, like a monomial would be like 3x or negative 5 or 8y squared. It's just one term. But when we take one of these terms, like 3x, and we add it to another one, like 5, or subtract in this case, that makes it a binomial because here's 1, 2 terms. They are separated by addition and subtraction signs. So look at this one, 4y cubed plus 8x. That's a binomial because here is a monomial plus another monomial. They're separated by addition or subtraction signs, and there's only 2 terms here. Trinomial then would have 3 terms. So that could be something like 4x cubed plus 3x minus 8 because there's 1, 2, 3 terms. And then polynomial we typically assign to something that has more than 3 terms. So something like 5x squared minus 2, or 5x cubed minus 2x squared plus 8x plus 10. That's 1, 2, 3, 4 terms in this case. When we arrange polynomials, we typically arrange these polynomials by putting them in ascending or descending order. Ascending means that the exponents get larger. So we want to look at this and find the exponent that is actually the smallest, which would be this 2. And that would be the term that would come first because we want to make it go from small to large in ascending or increasing order. So then the next one, we have a 4, a 7, and a 3. Well, next in our order of numbers would be an exponent of 3. So take the sign with it, 2x cubed. That one's done. Then we're looking for the one that comes after the exponent of 3. Well, here we got a 4. That's a positive 4x, so we're going to add 4x to the 4th. And the last one here, then, we would just say plus 4x to the 7th. That is in ascending order. The more common way we order polynomials is what we call in descending order. This one's used most often, so this is the one we'll use in class. When we have descending order, we want it to go from the degree of the polynomial and get smaller. So let's look at the degree of this polynomial. Well, the largest exponent is 8, so the first term we're going to have is x to the 8th. Then we look and we've got a 2, a 6, and here in this case we don't have anything. Well, if it doesn't have anything, the degree assigned with it is 0. So we got 2, 6, and 0. Well, 6 would come next as we're trying to get our exponents to decrease. And then our exponent of 2 would come next, so plus 3x squared. And finally, our constant is always going to go on the end when we go in descending order. When we add or subtract polynomials, we can do it either vertically in this case or horizontally. So we're going to look at both. Vertically, you want to line up your exponents. So in this case here we have our numbers, so we can just add them together. So 1 plus 2 is 3. Then here, check our x and our x. Those are like terms, so they should be lined up with each other. So x plus 3x would be 4x. Now this was a positive 3, and we need a sign between this. So since 1 plus 2 is positive 3, let's go ahead and put a sign in front of it. Yeah, we have another term in front of this. So when we look, here our x squareds are like terms. And there's a 1x squared plus 2x squared. So 1 plus 2 is 3, and we keep the x squared. We leave it alone, that base. But again, we need a sign between these two. Well, this one here was a positive number, so we're going to put an addition sign between them. And then that would be our final answer. On this side over here, you want to match up your polynomials so that you're matching like terms. So for example, the x squared goes with this x squared. This is like saying 3x squared plus x squared, which is 4x squared. Then we would say, okay, well now we've got like 4x plus 4x. Those are like terms because they both have an x. 4x plus 4x would be 8x. And then finally, we have something like 8 and 1. They're both constants, so 8 plus 1 would be 9. And then that would be our final answer. Subtraction is a little different, and often I encourage my students to do the extra step in subtraction so you don't make a careless error. So we're not even going to go ahead and jump right into this. We're going to change this problem. There's nothing going on at the top. The top, we're just going to go ahead and transfer it. So 5x squared plus 11x plus 3. Now we want to make sure that this lines up with our like terms. If not, we leave a space. So now look at this subtraction sign. It's outside the parentheses, which now means we've got to distribute it to every term. So negative times 2x squared is negative 2x squared. Negative times negative 3x is positive 3x. Negative times 7 is negative 7. Now we're ready to add straight down. So 3 and negative 7 are like terms, and they combine to give me negative 4. 11x and 3x are like terms. They combine to give me 14x. 5x squared and negative 2x squared are like terms. Those two are going to combine to give me 3x squared. And then that would be my final answer right here. Now, look at that compared to this problem here where we're dealing with our horizontal subtraction. What I suggest for my students to do is there's nothing going on outside this parentheses, so let's go ahead and take it out. 3x squared minus 2x plus 8. But we do want to go ahead and distribute this to both pieces. So the negative with the x squared is negative x squared, and negative with a negative 4 makes it a positive 4. Now we're ready to look for like terms. 3x squared and negative x squared go together. You take the sign in front of it. In fact, if you want, you can rewrite this as 3x squared, and then that negative x squared goes together. Then we look and we say, okay, well, we've used that and that. Well, what about x? I don't see any other x's. Well, then just bring it down. But then I see here, so this is all by itself, but then here I see two constants right there. I have a positive 8 and I have a positive 4, so those would go next to each other. So now we can just combine like terms. 3x squared minus x squared is 2x squared. Then I don't have any other x's, so minus 2x. And then here, 8 plus 4 would be 12, and then that would be my final answer.